Good evening, everybody. Myself, Arighna Bhattacharjee, and I will be presenting the paper of paper ID 167 titled Development of Indium Gallium Phosphide Gallium Arsenide Dual Junction Based Solar Cell Device to calculate and analyze key solar parameters utilizing Silvaco TCAD simulations. I am presenting the paper on behalf of my co-authors Arjit Mandal and Dr. Indranil Maiti. So first of all, as we know, the solar cell works on the simple property of photovoltaic devices. It um, yes, it traps the incoming light as photons in the anti-reflective coating layer and creates an electron-hole pair. The electron then travels to the N side and the holes travel to the P side, generating the photocurrent. And this is how the solar cell converts the light energy to the electric energy. So this is a simple PN junction, single junction solar cell. Now comes the question then why to use multi-junction or any dual junction, triple junction solar cells. The key differences are the material used in single junction solar cell is a singular material, primarily silicon or germanium based. But in multi-junction solar cell, it is using multiple semiconductor materials, indium gallium phosphide, gallium arsenide, etc. The efficiency in single junction solar cell commercial efficiencies range from 15 to 22%, whereas in multiple junction solar cells, the efficiencies are more than 22%, and in labs under concentrated sunlight, it is over 40%. The absorption range of single junction solar cell is limited to the band gap of the material it is constructed with. So as it is only made up of one material, the band gap and the absorption range is very small. Whereas in multi-junction solar cells, due to a wide range of multiple band gaps of multiple materials that you used, the absorption is more and it can be absorbed by many different materials in the multi-junction solar cell. The performance of multiple junction solar cell also excels than single junction solar cells. Now coming to the proposed structure, this is on the left side, this is the meshing profile of the proposed solar cell in the plotted in the Tony plot of Silvaco TCAD. We have used denser meshing in the thinner layers and broader meshing in the wider regions. This is the structure dimensions for each cell in the dual junction solar cell. We have used the window layer, then the emitter base and the BSF layer, then the tunnel emitter layer, then the tunnel base layer. Then again for the bottom cell, we have used the window layer, emitter layer, base layer, the BSF layer, and then the substrate. These are the dimensions and the materials used and the doping concentrations. To further elaborate on the structure, the window layer is constructed of indium aluminum gallium phosphide hetero compound. It is a semi-transparent layer which allows the photons to get trapped and pass to the underlying layers, thus providing photo generation. It provides minimum reflection and more light absorption. Now coming to the top cell, indium gallium phosphide cell, and consists of the p-type doped emitter layer and then the n-type doped base layer. It absorbs high energy blue photons. Why? Because the high energy blue photons have lower wavelength. By this formula, lambda equals to Hc by Eg band gap. As indium gallium phosphide has a higher band gap, it traps the lower energy, higher energy and lower wavelength blue or the ultraviolet photons, and it traps them. The lower energy photons or the higher wavelength photons can pass on to the next regions. Then comes the back surface field layer, BSF layers of the gallium arsenide layer. It's a narrower band gap than the top cell. It creates the electric field to collect minority charges. It creates potential barrier and reduces the recombination losses and pushes the minority carriers to the active region. Then comes the tunnel junction. Tunnel junctions are thin and highly doped layers which provide the series connection between the top cell and the bottom cell. These provide the low resistance series connection between the top and the bottom cells, thus adding up the current densities of the top cell and the bottom cell. Similarly, the bottom cell, on the other hand, absorbs the low energy red or the high wavelength lights and the infrared photons because it has a lower band gap and higher wavelength. And then we have the anode and the cathode metallic contacts. Coming on to the simulation methods, we have used the output models of temperature equals to 300 Kelvin. We have worked on the standard test conditions. These are the output parameters used in Silvaco TCAD. Some of them are op.int for optical intensity, on.band for conduction band, valence band, etc. The light beam used is AM1.5G. This is for the air medium 1.5 air density, which is the standard global density of a sun ray beam. To define the material composition of the hetero compounds of indium gallium phosphide and aluminum gallium phosphide, we have used the syntax of Atlas manual, wherein the XComp 0.49, we can see in the syntax that XComp means the gallium percentage or the gallium parts of indium gallium phosphide. Therefore, the indium composition is 51%. Next, in the indium aluminum gallium phosphide, similarly, we have the XComp and the YComp for the XComp for aluminum percent, YComp for the gallium percent. Similarly, we can get the indium percent of the composition as well. Coming on to the results.
So please conclude, Mr. Bharat.
Yes, sir. Thank you. For the results, this is the photo generation profile of the proposed cell. It is higher in the higher regions due to more absorption. In the emitter layers, it is higher as well. It decreases as we go vertically downwards in the proposed cell. These are the values of the dual junction solar cell bias. This is the open circuit voltage. This is short circuit current density, fill factor, efficiency, and the power maximum. The results of this photo generation, as previously said, this is the peak power max, the maximum electric power output as the solar cell. This is given by the cathode current multiplied by the anode voltage. It is maxed in the knee region of the IV characteristic curve. In the short circuit current density, as we can see, it comes around 1.75. The conversion efficiency, as shown in the previous slide, we have got the efficiency as 25.55%. The fill factor reflects how well the solar cell's voltage and current characteristics match the ideal. It is seen that it very much is like an ideal IV curve. Therefore, we have got a fill factor of 88%. This is the energy band diagram. To conclude, the studies given by us show that the indium aluminum gallium phosphide used as a window layer provides very optimized fill factor of 88% and quite generous 25% efficiency in the solar cell. Thank you.
So good evening, esteemed dignitaries, guests, and attendees of this conference. My name is Saurabhi Biswas, and I'm currently an Electronics and Communication Engineering student of Institute of Engineering and Management, Kolkata. So I have executed this research work under the guidance and mentorship of Dr. Indranil Maiti. So the title of my paper is a comparative analysis of the structural and electronic properties in 2D transition metal dichalcogenides, MOS2 and MOSE2 based on DFT calculations. So coming to the outline of this work, we have performed a comparative analysis of the structural and electronic properties of MOS2 and MOSE2 using the Gaussian 09 and the Gauss-View 6.0 suits. So this study is based on the density functional theory. So we have optimized the structures of the MOS2 molybdenum disulfide and MOSE2 molybdenum diselenide using the Gaussian and the Gauss-View software, and we have got their lattice structure. From there, we have calculated their bond length, which is comes under the structural properties, and also we have calculated their HOMO-LUMO. ESP, and DOS, which comes under the electronic properties of the material. So through this study, so what we have tried is we have tried to explore the potential of the two-dimensional materials like MOS2 and MOSE2, which are important materials under the class of TMDs, known for their tunable band gaps and high surface areas. So now the question arises why it is so important to understand and read more about the electronic and structural properties of sensing applications. So the answer is that the properties are very crucial because this helps in estimating and directly influence the interaction between the sensor and the gas molecules. So the structural aspects like the crystal structure, the orientation, bond length, etc., are determined by how the gas molecules adsorb or desorb on the sensor surface, which will affect in turn their sensitivity and the response time of the gas sensor device. Also, the electronic properties like the HOMO-LUMO, the density of states, the electrostatic potential impact the charge transfer mechanisms between the gas molecules and the sensing material, which alters the sensor's conductivity or the resistance. So, therefore, these properties are very essential to be studied. So then comes the simulation considerations. So here I have considered a pristine sheets of MOS2 and MOSE2. I have considered a 2x2 lattice crystal of them with 8 sulfur or selenium atoms and 4 molybdenum atoms respectively. So first, the first principle DFT calculations have been carried out using the software as already mentioned, and I have used the B3LYP functional and 321G as the basis set. So from there, I have calculated the bond length, HOMO-LUMO, and the ESP plots using the Gaussian and the Gauss view. But I have calculated the DOS or the density of state spectrum using the Gaussian software. HOMO-LUMO gap is another important criteria in sensing devices. So I have calculated that using the given formula. So next, coming to the results and discussion. So as we can see here, both of the two materials have a layered hexagonal crystal structure. So we have calculated the bond length using the Gaussian and the Gauss view softwares. So the MOS bond length in case of MOS2 and the MOSC bond length in case of MOSC2 is found to be 2.42 Armstrong and 2.60 Armstrong respectively. So the explanation for the larger bond length of MOSC2 is that the selenium atom is larger in size in compared to the sulfur atom. Also, this is very clear that shorter the bond length typically indicates a stronger bond, but it also influences the strength of the sensing material in order to interact with the gas molecules that are present. Another important factor is the interactions present between the layers of these materials are the weak van der Waals forces. So this is a very beneficial factor from the point of view of nanoelectronics, because nanoelectronics need precise material thickness control. So using that, we can control the thickness of these layers without the layers getting disrupted. Next, coming to the HOMO-LUMO. So HOMO stands for the highest occupied molecular orbital and LUMO stands for the lowest unoccupied molecular orbital. So here, under each image, the corresponding HOMO-LUMO energies are mentioned. From these energies, we have calculated the corresponding HOMO-LUMO gap. So for MOS2, the gap is 0.024 electron volts approximately, and in case of MOSC2, it is 0.029 electron volt. So basically, by convention, a smaller gap signifies higher chemical reactivity but lower kinetic stability, whereas a larger gap signifies weaker reactivity and greater kinetic stability. So as we can see, there are various color gradients in this HOMO-LUMO plot. So this have definite meaning. Like the red color signifies the electron density in these regions is high, whereas the green regions signify that the electron density here is low. Next, coming to the electrostatic potential. So the ESP plots generated from the Gauss view software highlight the key reactive sites in a molecule. So these plots use a definite color scheme to indicate the charge distribution. So the red regions indicate that the areas are rich in electrons with partial negative charges. So the blue color indicates electron deficient regions with partial positive charges. Yellow represents slightly electron-rich regions, and cyan blue represents slightly electron-deficient regions. So these colors help in identifying the electrophilic, which is electron loving, and nucleophilic, which is nucleus loving regions, critical for understanding the molecular reactivity. So we have generated these plots using the ISO value, taken the ISO value as 0.004, which was as required for the simulations. Next, coming to the density of states. So the dot spectrum is computed using the GaAs software. So where I have taken the existing orbital data that I've got after the optimization of these molecules in the Gaussian or the Gauss view software, and then I have uploaded it in GaAs and I have got the results as the spectrum that are shown here. So DOS basically illustrates how the electronic states are distributed by energy levels in a material. So the green lines on the spectrum typically indicate the levels of the HOMO, whereas the red lines correspond to the LUMO. So that means that the green lines represent the occupied orbitals and the red lines are basically the virtual orbitals. Next, coming to the conclusion. So our research demonstrates the strong potential of MOS2 and MOS2 as gas sensing materials. So by optimizing the 2x2 lattice structures, we have achieved precise bond lengths of 2.42 Armstrong for MOS in case of MOS2 and 2.60 Armstrong for MOSE in case of MOSE2, which are closely matching with the experimental data that is already existing. The electronic properties with HOMO-LUMO gaps of 0.024 electron volt for MOS2 and 0.029 electron volt for MOSE2 show high sensitivity for gas detection, making them ideal for sensor applications. The electrostatic potential plots highlight the reactive sites, crucial for understanding the gas interactions, while as the density of state spectra provides insights into the available electronic states. In summarizing, optimizing MOS2 and MOSE2 enhances their gas sensing performance, promising significant achievements in sensor technology. That is very important for us to understand these crucial parameters of MOS2 and MOSE2 so that we can tune them and get our required selective gas sensor devices. Thank you so much.
Hi, good evening, everyone. First of all, I would like to thank the organizing committee for preponing the presentation. So my topic is Advances in Colorimetric Detection, a short review of techniques for interdisciplinary application. So myself, I am Sreedevi. I'm a PhD scholar and doing my PhD in Material Science and Engineering at Qatar University. So the outline of the presentation is an introduction, then a colorimetric. Let's have a brief idea about the colorimetric techniques and the advantages of the colorimetric techniques. Then the various applications that we carry out through the colorimetric analysis, and then conclusion. So colorimetry is a technique used to measure the concentration of colored compounds in a solution. So usually for the colorimetric analysis, we will use dye solutions for the test, and it is a photometric technique which states that when a beam of incident light of intensity is passed through the solution, there is a chance for reflection, absorption, and transmission. So when the light is passed through the colored solution, some of the light will get reflected, some will get absorbed. So we will measure the absorbance for the analysis, and then the fundamental principle for this analysis is Beer-Lambert's law. That is, absorbance is equal to epsilon into B into C. And then let's move on to the applications and advantages of colorimetry. So actually the colorimetric techniques is very simple, cost effective, and it can be used for the quantitative analysis, and it has got a versatile application, and also it is highly sensitive. And moreover, this colorimetric technique can be utilized for various applications like for environmental monitoring, health monitoring, and food quality and freshness. And it has been widely applied for various purposes also. And the adopted methodology. Actually, this methodology has been developed by our group. It is like we will test for the analysis, we will use different dye solutions, and we will add our analyte. The analyte can be anything, like it can be a biomarker, or it can be any like for the food packaging, we are using so many items to preserve the food. So it can be a preservative or anything. Let the analyte be X. We will add the analytes to different dye solution, and we will focus on the color change of the dye solution. So we will not carry out the experiment only on the neutral solution, but we will vary its pH. From acidic to basic pH, we will vary to different pH, and we will check the color change. And after any visible color change, we will go for UV analysis to check the absorbance of the dye solution, and we will do the further analysis. So once the after the preliminary analysis, we usually focus for a 3 dye system for fabricating the colorimetric sensor. So we have a 3D printed colorimetric device for the analysis, and then we will connect the colorimetric sensor with a color sensor in a mobile phone, and we will this color sensor have an application where the RGB values are displayed. So each color have distinguished RGB values. So with the respect of the RGB values, we will carry out our further experiments, and we will find out the analyte that that are in our focus. So let's see the various applications of this colorimetric sensor. So in our lab, we have carried out different experiments with this colorimetric sensor for various applications. So first, let's see for the health monitoring, we have fabricated different sensors. So first, we will see for the ketone detection. So that is, we have fabricated a ketone sensor, ketone colorimetric sensor, by which we can detect ketone. So the effect of ketone is that in type 1 diabetics patients, there is possibility of variation of ketone level in the body. Usually in all people in the breath, we have ketones. So the healthy people and diabetic people have different ketone levels in their breath. So this developed colorimetric sensor is able to detect ketone that is present in the breath. So in the first figure, we can see that the acetone level that is detected by the proposed device and also with the KetoScan aligns together. That is, KetoScan is a device that is commercially available for detecting the ketone levels in the body. So our sensor and the KetoScan sensor aligns together. And the second figure in the B, we can see that we have detected the acetone in healthy patient and diabetic patient. So usually for the diabetic patient, the ketone level will be 1.7 ppm and higher. So if our sensor is giving a value of 1.7 or higher ppm, we can say that the person is having diabetics. So by monitoring the ketone level using the sensor, we can say that whether the whether the person who is under analysis is diabetics or healthy. And we have found a relationship between blood glucose and breath acetone. So as the blood glucose level increases, the breath acetone level decreases. So we have found a relationship with that. And also we have found the acetone level before medication and after medication in diabetic patients. So the patient with diabetics are having higher ketone levels before medication and have lower ketone levels after medication. And the other analysis that we have carried out is H2O2 detection. H2O2 is used as a biomarker for lung inflammation. So by detecting H2O2 in breath, we can identify whether we are having lung inflammation or not. And we have carried out the similar experiments by using the dye detection method, and we have compared our colorimetric sensor with an NMR data, and we have found that both the results align well with each other. And when the environmental monitoring is concerned, now the environmental monitoring research area has gained much attention. So we have fabricated this colorimetric sensor for detecting ammonia in water. So ammonia levels in water will vary according to different areas and also due to the presence of some other chemicals. So if the ammonia level is higher, it can affect the aquatic living organism. So the monitoring of ammonia in water is good for aquatic and also for the humans. So we have fabricated a 3D printed sensor. The figure is given in B, and we have found that using the colorimetric sensor, we could effectively detect ammonia. So in figure, this is a comparative table with already available reported sensors for ammonia detection. And we found that the limit of detection of our colorimetric sensor is much lower when compared to the other reported sensors. That is, we could detect ammonia to a much lower ppm, that is 1.61 ppm, rather than other sensors in the market. And also we have detected formic acid, methanol, ethanol colorimetric sensor. In that, what we are doing is, we know now currently carbon dioxide reduction has gained attention due to global warming, and also reducing carbon dioxide in the atmosphere is a active area of research. So we have to know which are the product that has been reduced, where the carbon dioxide is reduced with several experiments. So the products that we can detect with our sensor is formic acid, ethanol, and methanol that has been produced due to CO2 reduction. So our sensor, we can distinguish, we can identify whether it is formic acid, ethanol, or methanol. So usually this formic acid, ethanol, and methanol that is in liquid phase is determined by NMR experiments. And now we have proposed a colorimetric device by which we can identify these products. So we know this colorimetric device is user friendly, and also it is simple like analytical device. So we can replace NMR device with this colorimetric device, so that we can detect formic acid, methanol, and ethanol. So in this figure, we can see this is the comparative data of colorimetry and NMR for this detection of formic acid, ethanol, and methanol. And when food monitoring is considered, we have developed two distinguished sensors for detecting sodium nitrate and also trimethylamine. Sodium nitrate is used in packaging meat products to improve shelf life.
Ms. Sreedevi, please summarize.
Yeah, so sodium nitrate is used as used in packaged poultry to improve its shelf life. So we have fabricated a sensor by which we can detect sodium nitrate. Sodium nitrate is toxic carcinogenic compound. So if it is intake by humans, it can lead to several carcinogenic diseases. So in this, this is a practical application of sodium nitrate detection. So we have utilized chicken which is coated with sodium nitrate, and we have dipped in our dye solution, and we have found color change with the presence of sodium nitrate. And also with the trimethylamine detection, we have fabricated a paper colorimetric sensor. As the fish decays, trimethylamine releases more from its skin. So we can detect using our colorimetric sensor the freshness of the fish available in the market. And I would like to conclude my presentation as the recent developments in colorimetric detection techniques have revolutionized various fields by providing rapid, cost-effective, and user-friendly solutions for detecting wide range of analytes. And also the advances in the colorimetric techniques have techniques such as nano particle-based sensors, smartphone integration, and also smart materials have significantly enhanced its specificity, sensitivity, and applicability in various fields. Moreover, colorimetric techniques continue to evolve, promising an even greater impact in fields such as healthcare diagnosis, environmental monitoring, and food safety. Also, colorimetric detection continues to play a vital role in addressing global challenges and improving the quality of life. And these are the references. And I would like to conclude my presentation.
Good evening, all. Welcome to the Composite Materials for Environment Protection and Remediation. Thank you one and all to giving me an opportunity to present a review article. I am pursuing my PhD under guidance of Jaiprakash HV. He is an associate professor and NCC officer in Department of Chemistry, Sri Siddhartha Institute of Technology, Tumkuru. My today's presentation is about the nanoparticles for defluoridation of groundwater. It's a review article. Now, the introduction part. For all living forms, definitely we need to survive by using stay healthy and satisfy their basic needs by using purified water. And approximately 75% of the Earth's surface is covered with water. Fluorine is a pale yellow-green caustic gas that is essentially nano-existent in the natural environment in basic form. Actually, I have given
Miss
about
Bhavya, your slides are
Yes,
not
sir.
moving. Have you
Is that
moved the
okay?
slide?
Yes, sir.
It's not moving. Please put it on the presentation mode. Presentation mode.
I have given, sir. Now,
Yeah,
is it
now
visible, sir?
it's moving.
It's moving, sir.
Yeah.
Okay, okay, sir. Here we have selected the fluorine part because my research work is about the defluoridation. So I have put the slides about fluorine. And fluorine is a pale yellow-green caustic gas that is essentially a non-existent in the natural environment in the basic form. Fluoride can be found in both groundwater as well as in the surface water in the form of nearly dissociated fluoride ions. Fluoride can enter the human body through food, through industrial exposure, through medications, cosmetics, and also the other sources of drinking water. One of the most active areas of research for the purification of contaminated water is nanotechnology. Nowadays, it's very useful, which is the synthesis, development, and the specification of nano-sized particles. Nanoparticles are the contain many active sites for adsorption. It has a good adsorption qualification, free active valency, surface energies of nanoparticles, high reactivity, compact size, great catalytic activity, and high surface area. Next, the defluoridation techniques which we use for the removal of fluoride from drinking water are adsorption, precipitation, ion exchange, nanoparticles, nanofiltration, freeze concentration, reverse osmosis, bio-nanocomposites, carbon-based adsorbents, dialysis and electrodialysis, electrocoagulations, and hybrid methods. And first, we'll move on to what about the adsorption. Usually, the method used for defluoridation is commonly used as the adsorption process because it's a low cost, easy use, high removal efficiency, and adsorbance regeneration. Adsorption technique has a lot of potential for removing fluoride from the contaminated groundwater. The kind of adsorbent and adsorbate, the presence of additional pollutants, and the experimental conditions also depends, all affect the adsorption. Adsorption has a fluoride removal efficiency of between 56% to 100%. The main factors influence the removal of the fluoride include the pH, the starting pH, pollutant level, the kind and the dosage rate of the adsorbent, the water flow rate, contact time, temperature, and the solubility of the contaminant. Next process is about the precipitation. In the precipitation, we use lime, bleaching powder, and alum salts. We add all these to the standard water treatment processes as part of this approach. The precipitation method is rarely used due to its high chemical costs, high residual aluminum dosage, formation of sludge with a high content of toxic aluminum fluoride composite, batch technique, limited amount of water being treated, and therefore it is not commonly used technique. And nanofiltration, due to its exceptional and high membrane selectivity, this approach seems to be the most effective of all membrane approaches for the removal of fluoride. When it comes to the concept of treating water, nanofiltration is one of the fluoridation procedures that work when compared to other membrane techniques like reverse osmosis and electrodialysis. And next we'll move on to the reverse osmosis process. Reverse osmosis is a physical process where solvent flows towards the less thickened side of a semi-permeable membrane when hydraulic pressure is applied to the higher level side of the membrane above and above the osmotic pressure. Next we'll move on to the dialysis and the electrodialysis. The principle of dialysis relies on solutes diffusing through the membrane to be retained. Using direct current voltage electrochemical segregation of ions through resin membrane is known as the electrodialysis. And the other method is the ion exchange method. Although the treatment is not it's not so cost effective due to its high cost of the resins, they may be easily regenerated. And the disadvantage of this ion exchange process is that the regeneration process, it produces a lot of garbage that is heavy with fluoride, and this is cannot be disposable easily. And next, we'll move on to bio-nanocomposites and carbon-based adsorbents. Bio-nanocomposites are useful adsorbent for removing fluoride from water. The disposal issue with plant biomass, agricultural waste, and industrial byproducts can be resolved by using it for effective fluoride uptake. And because carbon has a strong affinity for fluoride anions, carbon-based adsorbents have been extensively researched for the removal of fluoride. The other method is the electrocoagulation. It's a useful method for removing fluoride, but the clean water's high turbidity will be a problem in between. Means some water will be providing turbidity during the process. This approach requires an electric supply, and defluoridation studies have shown the charge loading is an essential force.
Yes,
Then
please summarize. Please
Okay.
summarize.
Okay, sir. Okay. This is a graphical representation of the different adsorbents used to treat the contaminated fluoride. And the different adsorbents for fluoride removal are oxides and hydroxides, biosorbents, geomaterials, carbonaceous materials, industrial products, and byproducts, magnetic nanoparticles. We use some oxides and metal oxides and hydroxides to remove heavy metals from the water, polluted water. And biosorbents, it is a percentage to 50 to 90% removal. For treating water, that makes use of widely accessible biomaterials. Geomaterials are the materials that draw inspiration from geological systems. Rock, clay, granular materials, such kind of materials are geomaterials. Carbonaceous materials means the materials which contains the carbon materials used for the defluoridation. Industrial products, example, bone char. It's a granular substance that is made by using animal bones. By modifying bone char also, we can remove the fluoride. And the magnetic nanoparticles, due to their large surface area, high selectivity, reactivity, and magnetic nanoparticles vary to remove fluoride from the groundwater. And the conclusion is the numerous techniques were examined, including reverse osmosis, nanofiltration, nanoparticles absorption, etc. The technique that was most frequently used to remove fluoride is the adsorption process because it has many benefits. In order to continue the removal of fluoride, future requirements include low cost and highly developed systems with minimal wastage and disposal problems also. The most widely used titanium hydroxide and oxides demonstrated the best adsorption capabilities. And high adsorption capacities and regeneration capabilities are the benefits of carbonaceous materials. Removal of fluoride from various industrial goods and byproducts, large adsorption capacities, and various types of magnetic particles also has some adsorption properties. And thank you one and all to giving an opportunity to present the review article of the nanoparticles used for defluoridation of groundwater.
So starting from introduction, refrigeration is a mechanical device which maintains the lower temperature as compared to surrounding is known as refrigerant. Historically, acting 34, the first practical refrigerating machine built by Jacob Parkins based on elaborate expansion designed to cool temperature using a vapor compression cycle. They are extremely used the field of various types of cooling of space, substance, or systems to lower and maintain the temperature below the ambient one while the minimum heat is ejected at a place of higher temperature. Here is the schematic diagram of the vapor compression refrigeration cycle starting from the compressor, then a condenser, then expansion bomb, and last one evaporator. The cycle involves the circulation of refrigerant through the four main components. Here is the pressure volume diagram for the refrigeration cycle. In a left-hand side, there is a saturated liquid line, and right-hand side saturated vapor line. And saturated line and saturated vapor line means that point is known as critical point. Starting from the first generation between 1830 to 1930, the old refrigerant are ether, like as ethers, ammonia, carbon dioxide, water. Then after in second generation 1931 to 19, that is ammonia, carbon, fluorocarbons, hydrochlorofluorocarbons, and hydrofluorocarbons. Then third generation refrigerant, that is 1990 to 2010, hydrofluorocarbons, and hydrocarbons. Fourth generation 2010 onward, zero ozone depletion potential, global warming potentials. Refrigerant nowadays are using like as R600, that is isobutane, and R290 propane. Machine learning. Machine is the branch of artificial intelligence that focus on developing algorithms and statistical models that enable computers to perform tasks without being explicitly programmed. And this is the subfield of artificial intelligence, like as computer vision, fuzzy logic, genetic algorithm, artificial neural network, and an expert system, deep learning, and machine learning. It involves the use of data and iterative learning to improve the performance of the system or model in making predictions or decisions. These are some literature review that using to get at all using LPG refrigerant. These some authors are doing different type of refrigerant like as LPG refrigerant, R134, and liquefied petroleum gas, LPG, and using mixed with nanoparticles, R600, and they predicted some the result of the vapor compression refrigeration cycle like coefficient of the performance, cooling effect, and power consumption. These are the activity of machine learning. Understand the type of data in the given input data set, and then after explore the data to understand how much the quality of our data, and then explain the relationship between the data and elements. Then after find the potential data in issue. If I have any problem in data, so we can rearrange the data and we can do the necessary remediation if needed. Apply pre-processing step and in necessary. Then after once the data is prepared for modeling, then the learning talks start off. The input data are divided into two parts. If I have 100 data, then we have 70 data for the testing, 70 data for the training, and 30% data for the testing data. In case of the supervised learning, in supervised case of learning, we have to know input and output both data, and based on the data, we have to predict some output. Consider some different method to learning algorithm for the selection. Step for machine learning: preparing the model, learning, performance evaluation, and performance improvement. In case of already discussed supervised case of learning. For the mathematical model, data reduction is how can use the data reduction in machine learning. Here, y is the dependent, that is output variables, and alpha plus beta x. In case of the, if I have two variables, that is y is equal to m expressed in the relationship between the independent and dependent variable as shown in a figure. That is simple linear regression model. Here, if more than two data like V0 3 to 4 data, we are using the output of V0 plus V1 x plus U2 x. Here the V1, V2 is the slope coefficient, y is the response variable output, and x1, x2, x3 is the independent variables. Conclusion from the literature review: in recent years, numerous studies have been done on the vapor compression refrigeration cycle via modification of design and replacement of old refrigerant with new generation refrigerants such as hydrocarbons and hydrofluorocarbons blends. Nowadays, refrigerant with distressed nanoparticle, different type of nanoparticle, that is TiO2, CiO2, graphene. This size varies from 10 to 100 nanometers, is known as nanoparticle, thus defined to improve heat transfer performance using a smallest particle fraction of nanoparticle in these base refrigerant. This chapter provides a summary of investigation focused on analyzing the coefficient of performance, power consumption, and cooling effect using machine learning techniques. These are my some researches. Thank you.